Good day, grade 10 students. This is again Sir RJ Olarve and welcome back to the video tutorial for our subject, Science 10. So last time, we talked about the introduction to gases. And there we've mentioned the different assumptions about the nature of gases or the general properties of gases as well as the different measurable properties of gases. And this time, we're going to have the different laws of chemistry that govern the behavior of gases. But before we proceed with the discussion proper about the different laws of chemistry that govern gases, so let's have first a different lesson objectives. So in this lesson, you are all expected to first know the different laws that govern the behavior of gases. Second is to know the different person behind the laws that govern the behavior of gases. Third is to know the relationship that exists between the measurable properties of gases, and lastly is to familiarize yourself with the different formula that is needed in order for you to understand the different laws that govern the behavior of gases. And as an introduction about the different laws of chemistry that govern the behavior of gases, generally there are only 6 laws of chemistry that govern gases. And what are these? So we have the Boyles Law, Charles Law, Gay-Lussac Law, Combined Gas Law, Avogadro's Law, and lastly is the Ideal Gas Law. But for this video tutorial, we're going to discuss the Boyles, the Charles, and the Gay-Lussac Law only. And let us begin with the Boyles Law. So Boyles Law is commonly referred to us as the volume-pressure relationship. So recall lang natin, di ba, meron tayong 5 na measurable properties of gases. And dalawa sa 5 yon ay ang volume and pressure. And for this first law of chemistry that govern the behavior of gases, ang dalawang involved ay ang volume and pressure. And this is actually proposed by Robert Boyle in the year 1662. And here we have the picture showing Robert Boyle. And another thing about this Boyle's law, it states that the volume of a certain gas held in a constant temperature is inversely proportional to the pressure exerted by the gas. So take note of the word inversely proportional. When we say inversely proportional, as one quantity increases, so the other quantity will decrease, or vice versa. Kung isa naman ay nag-decrease, yung isa naman ay mag-i-increase. So ganun yung pinaliwanag ni Robert Boyle in his Boyle's Law about the relationship of volume and pressure. And take note of this formula wherein P1 V1 is equal to P2 V2, wherein P1 is the initial pressure, wherein V1 is the initial volume, P2 is the final pressure, and V2 is the final volume. And in order for you to know more about this formula, let us have a sample problem. Okay, the pressure of a gas in 2.5 liters at a constant temperature is 1.2 atmosphere. So what would be the pressure in millimeter in mercury if the gas is compressed to 2.0 liters? So the first thing you need to do is to analyze the problem. And then after nyo siyang i-analyze, so the next thing you need to do is to write all the given values. So we have V1, which is the initial volume is 2.5 liters. Ito siya. And then next is the initial pressure, which is 1.2 atmosphere. So ito siya. Next is the V2, which is 2.0 liters. And the unknown quantity is the final pressure. And then from this, so we're going to write the formula that we're going to use. So we have the original formula, which is P1 V1 is equal to P2 V2, wherein kung i-derive natin, okay, yung P2 kasi yun yung kailangan natin dito. So ang mangyayari dyan, i-divide lang natin both sides by V2 para maiwan yung P2 dito. So dinivide natin siya, and dahil dinivide natin siya both sides by V2, so makakancel yung V2 dito. And it will give you the formula P2 is equal to P1 V1 over V2. And after nating makuha yung formula in finding for our final pressure, next thing you need to do is to have the solution. For the solution, So copy the formula and then substitute all the given in the formula. So we have the P1 is 1.2 atmosphere and it will be multiplied by our V1 which is 2.5 liters all over our V2 which is 2.0 liters. So ito siya. Ayan. In the next, no? Perform the indicated operation. So 1.2 multiplied by 2.5. So it will give you the product of 3.0 atmosphere liters. And then this time, so makikita nyo, pwede nating makancel sa liters. So dahil same unit yan, so cancel. At ang maiiwan na lang is 1.5 atmosphere. Pag pinform natin yung 3.0 divided by 2.0, so it will give you the answer 1.5 atmosphere. Pero, balikan natin yung question. Sabi dyan, what is the pressure in millimeter in mercury if the gas is compressed to 2.0 liters? So, take note, ang nakuha pa lang natin na value ng final pressure is expressed in atmosphere. And this time, kailangan natin siyang i-convert into millimeter in mercury using this formula. Kasi 1 atmosphere is equal to 760 millimeter in mercury wherein tinuro ko to dun sa nakaraan natin na video tutorial. Okay, so this time, copy lang natin yung 1.5 atmosphere. Ito siya. And then multiplied by 760 millimeter mercury and then nasa denominator yung 1 atmosphere para makancel natin yung unit ng atmosphere. Next is perform the indicated operation. 1.5 multiplied by 760 divided by 1. So it will give you the answer for the final pressure which is 1,140 millimeter in mercury. So this is your final answer. In next gas law, we have the Charles law. Okay, so Charles law was proposed by Jack Charles and he observed the relationship between volume of gas and now it changes due to the temperature. So kung kanina, ang concern natin is all about volume and pressure, this time, Jack Charles, na napagtantuan niya na meron ding relationship between volume and temperature. That's why this Charles law is also referred to as the volume-temperature relationship. And it states that the volume of a fixed amount of gas maintained in a constant pressure is directly proportional to its absolute temperature. And take note of the word directly proportional. When we say directly proportional, ito yung kabaliktaran kanina nung inversely proportional. Kung sa inversely proportional, pag tumaas yung isa, bababa yung isa. This time in the directly proportional, pag tumaas yung isa, tataas din yung isa. Okay, pag tumaas yung volume, tataas din yung temperature. Pag bumaba yung volume, bababa din yung temperature or vice versa. Okay, and we are going to use this formula wherein V1 over T1 is equal to V2 over T2, wherein Ti or T1 is equal to initial temperature, Vi is the initial volume, T2 is the final temperature, and then V2 is the final volume. And para mas ma-analyze pa natin ng mas maganda itong formula na to, let us have our sample problem. So for our sample problem, okay, the volume of a gas at 27 degrees Celsius is 380 milliliters. So what would be the volume of the gas at 57 degrees Celsius if the pressure is held constant? So take note also, ang ating temperature ay naka-express in degrees Celsius at na-mention ko sa inyo nung nakaraan na video tutorial na laging dapat siya i-express sa Kelvin. So later on, need natin siyang i-convert muna, Pero next natin gagawin dyan is i-analyze natin yung given na word problem. So ngayon, ana-analyze natin ano yung nawawala. Sabi dyan, what would be the volume of the gas? Okay, so yung volume ng gas yung nawawala and this volume of gas is our V2 or final volume. Okay, so list down natin yung mga given. So we have T1 is equal to 27 degrees Celsius. V1 is 380 milliliters. T2 is 57 degrees Celsius. And then our unknown is V2 which is our final volume. So sabi ko kanina, kailangan si temperature ay kailangan mo nating i-convert into Kelvin. So, list down natin siya dito. We have the T1 and the T2. Paano ba natin gagawin to ngayong Kelvin? So, recap lang natin itong formula na to wherein Kelvin is equal to degrees Celsius plus 273 Okay, and using this formula, convert natin ngayon yung temperature na naka-express ng degree Celsius papunta kay Kelvin. So, paano yan? So, copy lang natin yung value ng T1 which is 27 degrees Celsius papunta dito sa formula na to. Okay, so ito na siya. Replace lang natin siya, 27 degrees Celsius, and then just add 273 and it will give you the answer 300 Kelvin. And that is our initial temperature. And for our final temperature, so we're going to substitute, okay, itong 57 degrees Celsius na to. So add lang natin ulit yung 273 from this formula. It will give you the answer 330 Kelvin. So therefore, ito na yung absolute temperature natin at ito yung gagamitin natin mamaya doon sa ating formula. So now we are done in identifying and listing down of the given values for our problem. And after nating malist down yung mga given, so the next thing we need to do is to have our formula. Okay, derive tayo ng formula at ang kailangan nating mahanap ay V2. V2 yung formula para sa V2. So paano natin to gagawin ngayon? Using the original formula wherein V1 over T1 is equal to V2 over T2. Paano natin ngayon kukunin yung formula para sa V2? So una muna is i-cross multiply natin siya. So cross multiply natin to, magbibigay sa atin ng V1 T2. Tapos cross multiply ulit, magbibigay sa atin ng V2 T1. So ito. And then, para maiwan yung V2 dito, kailangan natin siyang i-divide both sides by T1. Right? I-divide both sides by T1. Makakancel yung dalawang T1. Will give you the formula V2 is equal to V1 T2 over T1. And next, for the solution, so just copy our formula for the final volume. Wherein ito yun, V2 is equal to V1 T2 over T1, and then next is substitute natin yung mga nasa given kanina, which is ang ating V1 is 380 milliliters, ang ating T2 is 330 Kelvin, and then our T1 is 300 Kelvin. Next, perform indicated operation. So multiplied lang natin 380 multiplied by 330, so it will give you the answer 125,400 milliliters Kelvin. Tapos divide lang natin yan sa 300 and it will give you the answer 418 milliliters. Okay, and therefore our final volume is 418 milliliters. So hindi naman sinabi dyan na i-convert pa siya sa liters, so no need to convert it to liters kasi ang volume naman can be expressed sa milliliters or liters or cubic centimeters. So that's our sample problem for the Charles Law. And now let's have the third and the last law for this video tutorial, which is the Gay-Lussac Law. So in the year 1808, a French scientist, Joseph Louis Gay-Lussac, did some experiments about gas reaction at a constant temperature and pressure. And he found out that the volume of reacting substances are always in small whole number ratio. And therefore, he states in this law that the pressure is directly proportional to the absolute temperature at constant volume. So, take note of the word directly proportional. So, ibig sabihin yan, kapag tumaas si pressure, tataas din si temperature. At kapag bumaba si pressure, bababa din si temperature. And that's why this Gay-Lussac law is also known to be the pressure-temperature relationship. And we use this formula wherein Pi over Ti is equal to P2 over T2, wherein Pi is our initial pressure, Ti is our initial temperature, P2 is our final pressure, and T2 is our final temperature. So in order for us to familiarize with this formula, so we're going to use it on our sample problem number 3. So we have a gas at 21 degrees Celsius as a pressure of 1.4 atmosphere. So you need to calculate the final pressure in millimeter in mercury if the temperature is changed to 54 degrees Celsius at constant volume. So this time, tignan natin yung given, yung mga given at ano yung hinahanap. So the unknown quantity is the final pressure. Okay, so na-identify natin yung unknown, and it's time for us to have the different given values. So for our TI, so we have 21 degrees Celsius. Again, naka-Celsius siya, pero mamaya na natin siya i-convert into Kelvin. Next is our PI, which is our initial pressure, is equal to 1.4 atmosphere. And our T2 is equal to 54 degrees Celsius. And unknown is our final pressure. And this time, so convert muna natin yung ating mga temperature, which is our TI is 21 degrees Celsius and our T2 is 54 degrees Celsius. So, same lang tayo nung kanina. So, we're going to use the formula in order for us to convert it papunta ng Kelvin. So, we're in Kelvin is equal to yung given na value for the degrees Celsius. So, just add 273. So, ito siya. So, lagay lang natin yung 21 degrees Celsius and then add 273. It will give you the answer 294 Kelvin. And then for our T2, so 54 degrees Celsius plus 273. So, it will give you the answer 327 Kelvin. So, take note of the given values, okay, for our given because we're going to use it sa ating solution. But first, let's derive the formula for the final pressure kasi yung final pressure yung kailangan natin. Okay, and using our original formula, we're in P1 over T1 is equal to P2 over T2. So from this formula, we're going to derive the formula in order for us to find for our final pressure. Wherein cross-multiply natin yan. P1 T2 is equal to P2 T1. And dapat ang maiwan lang na quantity dito is the P2. That's why you're going to divide both sides by T1. And then dahil may T1 dito, so cancel. And it will give you the formula for P2, which is P2 is equal to P1 T2 over T1. And this formula so will be used for our solution. So just copy the formula. P2 is equal to P1 T2 over T1. And then substitute natin yung mga given kanina, which is yung 1.4 P1 natin yan. And then 327 Kelvin is our final temperature. And then 294 Kelvin is our initial temperature. Okay, performed lang natin yan. 1.4 multiplied by 327. It will give you the answer 457.8 atmosphere Kelvin. Tapos, perform natin to, itong ating 457.8 atmosphere Kelvin. Divide lang natin yung 294 Kelvin. It will give you the answer 1.56 atmosphere. Pero take note, naka-atmosphere pa lang siya. Okay, at ang sabi sa ating sample problem, kailangan siyang i-express into millimeter mercury. So, tingnan lang natin dito. Ito pa rin yung solution natin. Okay, nandito na tayo sa phase we're in. We're going to convert this atmosphere going to millimeter in mercury. So, using this formula or this conversion once again, which is 1 atmosphere is equal to 760 millimeter in mercury. So, copy lang natin yung 1.56 atmosphere, tapos multiply lang natin yung 760 millimeter in mercury, tapos cancel yan, and then it will give you the answer. Final pressure is equal to 1,185.6 millimeter in mercury. So this would be the end of our discussion regarding the part 1 of our video tutorial with regards to different laws that govern the behavior of gases. And if there are things that are unclear to you, so don't hesitate to contact me at any of this contact information, Facebook, Gmail, and cell phone number. And as a reminder, once again, from 1 Corinthians 10 verse 31, when you eat or drink or do anything else, always do it to honor God. God bless, grade 10, and see you sa ating Zoom meeting this week.